Thank you all for coming to my talk. I'm very excited to be here. Thank you, EscapeConf, for having me here. It's a privilege to be here with so many experts in the multi-cloud space. My name is Anna Medina. I currently work as a chaos engineer at a startup called Gremlin. We do resiliency. We're a resiliency company. We currently offer a chaos engineering platform for folks to learn more about their systems and prepare for moments that matter. I've been coding since 2007. That means that I've done a lot of front end, I've done a lot of mobile applications, I've done college research. And then in 2016, I got started in chaos engineering. And the fun thing is that I had worked at credit unions, I had worked at colleges, I had worked at small tech companies, but nothing really clicked for me. It was like I was trying to be a generalist at all times. And then I got a chance to join Uber. I joined Uber as their first site reliability engineering intern, but it was a little bit interesting because I didn't just join a regular site reliability engineering team. I joined the chaos engineering team. And that was actually the first time that I ever touched systems, production, or infrastructure for that matter. So it was a pretty nuts to ramp up in 2 weeks and then end up on call during my third week. And this was actually touching our production infrastructure on calls and our chaos engineering stuff. So Uber decided to build their own chaos engineering platform because they felt that they wanted to transfer to the cloud, but they also were completely bare metal at that point, and they just wanted to make sure that those things were really resilient. But they weren't on the cloud, and when they were looking at the concept of chaos engineering, they looked at Netflix's open source project called Simian Army, and well, that only runs on AWS, and being completely out of 2 DCs in the US, they can't use that. So we built something internally, and that worked really well, and then I transitioned on to another team. The other team was cloud infrastructure. And that meant that we wanted to build a vendor-agnostic tool that allowed us to move Uber from bare metal data center to the cloud. So we were building this project that started off being called Blueprint, then Theo built in Go, and this would leverage the API of GCP and AWS so that we were in vendor lock-in. We very much wanted to be multi-cloud, hybrid. We wanted to have our edge services running on other cloud servers as well, but we wanted to make sure we were doing this in a very resilient way. I later left in 2018, and I joined Gremlin. And it was very much of like, I wanted to make sure that folks were thinking about building a good customer experience at all times, that their systems were resilient, and that their engineers were happy while being on call and not necessarily having too much pager fatigue. So today I'll be talking about chaos engineering. And to give a little bit of background about that, I'll talk about why something like this is currently needed. Our businesses' health and safety rely on applications and systems that will fail. I think most of us know that things are going to go down. Vendors might promise some pretty nice SLAs, but sometimes they're not met. And sometimes as a customer, we win with some chargebacks. But if you're that company that's providing those services, you want to make sure that you're constantly up. When we look at headlines, we have headlines like this that have been hitting for events like Black Friday. We have technical issues likely to cost retailers billions. Companies like Macy's, Lowe's hit by Black Friday technical glitches. Imagine being at a store on Black Friday that there's so many folks there, and then the cashiers are not working properly. Or let's say you're one of those, or just like me, that likes waking up at 2 in the morning on Black Friday just to shop online. I can't wait till Cyber Monday. And you can't necessarily check out. Your payments are not going through. Well, this is really frustrating when you're like, I really want that new Xbox. I really want to buy this jewelry for my partner. That's not fun. Then we also have other things like banks. We have headlines that have hit the news that include Wells Fargo accidentally foreclosed hundreds of homeowners just with a little bit of a code glitch. Customers report difficulty accessing Chase Bank Mobile and online bank, and Citibank website now down or working. So the customers of these banks, well, you can't check how much money you have. You can't necessarily send money. You can't possibly call your bank because all they're going to tell you is we're having some technical difficulties. We're really sorry. And you as a customer, you're frustrated. And if you're one of those engineers on there, Well, mega hashtag hug ops to y'all. It's definitely not easy when you look online and you see your company just getting blasted for having some issues, and you're trying your hardest to have a really blameless culture and try to work on this outage together and try to come up to a resolution at the fastest pace. Then, if you're a frequent traveler like I am, well, airline incidents, they kind of hurt. It sucks to be in the airport waiting and all they tell you is we're having some technical difficulties on our plane, or maybe you're just trying to book some flights and you can't cash out. So with headlines like computer problems, blame for flight delays, we see other headlines that go up to actual more things that concern safety. Pilots of doomed Boeing 737 MAX fought the plane's software and lost. This was just another software glitch that didn't necessarily get tested to the extent of like, how do we actually make sure this is working when it's needed? And this brings us to the fact that our company's brands get really hurt when we have all these outages, when we have any issues that affect our public image. So that brings us to measuring the cost of downtime. I'll be talking about chaos engineering, and one of the things that is really good to have as a reference is how to measure the cost of downtime for your product, your company. The way that we define this, and I believe this actually comes from a Gartner report, is that this is the cost sums up things that happen during the outage, such as revenue that is lost, the amount of purchases that couldn't get made, the amount of transactions that didn't get made. Then we have employee productivity. Your engineers have gone from working on the projects that they're trying to do to wrap up the quarter that y'all have already promised to your executive leadership, and well, that's loss. And you can kind of quantify that by the amount of hours an engineer has to pull away from their projects to go triage this issue. Then we have, after the outage, customer chargebacks. Breaching SLAs gets really expensive. I know for Uber's largest outage that happened in 2017 that doesn't have a postmortem out there, that was a worldwide outage that we had, and that meant that we actually had to give money back to our drivers. We had to give money back to our riders, and it was like we couldn't necessarily tell what riders were the ones trying to request rides. So if you go look, everyone received a little bit of a promotion on that one. That's kind of expensive when you think about the amount of users that Uber has. And then, of course, we have those things that are unquantifiable. The brand deformation. How much money is it hurting your brand by being down? If it's something that you really need right now, such as ride sharing, and there's more than one provider out there, it's very easy to be like, all right, I'm done with this one, I'm gonna go on to the next, and then that becomes your favorite because they were up when you really needed them, especially on that rainy day. And then you have this other unquantifiable thing, and that's employee attrition. A lot of folks don't wanna be working at a company that's always on the news because they're constantly having outages. Or there's also the part where if you're one of those SREs that is keeping these services up and you're constantly getting paged, well, you might just throw in the towel and be like, I don't want to be on an on-call rotation that has me working 60 hours a week. That's not healthy for me. I want a work-life balance of 40 hours. So just to kind of throw an estimate, Amazon is estimated to lose $220,000 per minute or $13.22 million per hour when they're down. And of course, if you think about their peak season, Prime Day, if they were down in Prime Day, this number is looking a lot higher. So why does this keep on happening? Well, we have these two Death Stars of microservices that the CEO of Gremlin likes talking about very much. These things are very outdated. They come from about 10 years ago. But every single little line on this graph represents a microservice, a server, a connection. And as you can tell, we're not stopping building more software. This complexity continues increasing. And then when you talk about the fact that we're trying to be on our bare metal data center, on our private cloud, on our public cloud, that complexity kind of quadruples. So how do we help make this better? We do this by breaking things on purpose. And that is a concept that has a very thoughtful approach called chaos engineering. Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. This is not about doing this of like, I'm just gonna run chaos engineering experiments and we're going to figure it out, you have to do this in a very thoughtful way. You have to do this in a very planned way. And you want to make sure that if you know that this experiment is going to break production, don't do it. You don't always have to start in production. You can slowly start off in staging, development, and later get onto production. At Gremlin, we like saying that chaos engineering is like an immunity shot, where you inject something harmful into your system in order to build immunity. So you get to kind of play a little bit of a doctor with your systems in a sense. The idea with chaos engineering is that we test proactively instead of waiting for an outage. We want to make sure that we're ready to take action before this outage hits. And as I mentioned, you have to do this in a very thoughtful way. So another way that we make sure that folks do this in a very thoughtful way is by putting some guardrails in our product. But in general, in the concept of chaos engineering, we have this definition of blast radius. Blast radius can mean I'm starting off with one host out of the hundreds and thousands of fleets that I have. What actually happens if I just shut down one host? Then you can slowly increase that to 5 hosts. Maybe you feel a little bit more confident and you want to go with percentages and you want to just affect 5% of your fleet. You see that chaos engineering experiment go successful where your dashboards, your observability tools are showing you that everything is up and running. And then you go and expand that blast radius. How does chaos engineering actually translate to the multi-cloud? Well, very much on yesterday's keynote. And you have to design multi-cloud with a lot of intent. And chaos engineering can actually help you architect your multi-cloud strategy. How? Well, there's actually various ways. One of my favorite ones that I like talking about is battle testing cloud providers. Being able to just randomly spin up instances on Amazon, Microsoft, Google, Aliba, Google Cloud, DigitalOcean, IBM, and then basically trying to find out, do they have the things that you need? Are they actually located somewhere that makes sense to have connected to the rest of your applications? And then how do they actually handle failure? If you were to shut down one of the hosts in any of these cloud providers, how long does it take for another one to get spinned up? How long does it take for your monitoring to actually catch this exchange? You can actually make the decisions of your multi-cloud strategy by doing a lot of testing prior to choosing them. How do you actually test for the consistency between clouds? Let's say that you're actually trying to have some databases running in 2 different clouds, and you want to make sure that if your primary is shut down on your first cloud provider, and you have your replica and a primary also running on your second cloud provider, is the cloud 1 primary being consistent with cloud 2 primary? And then let's say you actually shut down primary in one of them. Does your replica actually come back as primary without suffering any data loss? I know that when I did some testing on just setting up Redis straight out of the box, well, deleting your primary on it, a primary container for Redis, basically means that your secondary container for Redis becomes your primary. But there is that point that that replica had looked at primary prior to doing that and realized that it had gone empty as it was getting deleted. So you actually ended up suffering a data loss. So being able to figure out how your tools are actually going to transition to these failures really, really matters. And then you can also think about what cloud provider is going to be cheaper under peak traffic, when your CPU is ramped up, when you have your bandwidth maxed out, when you actually might also run some load testing and trying to find out how these charges are being affected. Then, let's say you actually start building out your cloud. How do you actually know that you're not being locked into a vendor? Or have you set it up in a way that you have your cloud providers, your DC connected, and you were to shut down one of your cloud providers and everything works magically? That's usually not the case. I know that when we were actually trying to do this for Uber, we tried to take a trip on the cloud, and well, that to us meant a lot of more questions. What microservices do we even need to move to the cloud in order for this to actually work? And then there's the question that you can also ask yourself, does it make sense to use Kubernetes? Maybe you don't need Kubernetes in your multi-cloud strategy. Maybe you do. being able to play around with different ways that these vendors do manage Kubernetes makes a lot of sense. And as I mentioned, what applications should I prioritize? If you're at a company like Uber that had hundreds and thousands of microservices running, I think I joined when there was 2,000. No, we had just reached 1,200 microservices. I left, and they had just hit 2,000. And I just heard someone talk, and they said they have 4,000 microservices running there. And when you think about that, how do you come up with that strategy of what microservices you should put on the cloud first, or prioritize to make a multi-cloud strategy on? Then, if you have a hybrid cloud, what is the latency between your resources? From maybe you have your front end running somewhere else, maybe you have your data storage running in another place. You can actually do this with a little bit of chaos engineer experiments around latency. And how are you handling errors and timeouts? Let's say that the latency between one cloud provider to the other, or just in general from where the user is visiting your website to where the edge on your front end is actually running. Let's say that you have a lot of latency for that user, and then they end up seeing a lot of 500 errors and is not handled in any way properly on the UI side. They also are having a terrible experience as a user. With chaos engineering, we can do a little bit of fire drilling to prepare us to respond quickly, calmly, and safety. And with that actually brings us to how do you actually verify that now that you've gone multi-cloud, everything is working perfect, or as perfect as it could be. And this is basically where I can start off of, like, when did you last test the failover between your clouds? Let's say that you have decided to go multi-cloud because you want to say that your cloud A goes down. Well, your cloud B can actually make sure that everything's working properly. And worst case, then you have your DC that will make sure that things are still up and running, or at least you have a front end and a contact page and a status page. Well, when was the last time you actually executed that failover, disaster recovery, or business continuity plan? A lot of folks don't necessarily actually do those. So being able to say, I have a runbook is great, but when did you actually sit down with your team and run it? Once again, how does the latency affect the connections between the clouds? Being able to verify that you're not breaching any SLAs matters a lot. And sometimes people are just like, we'll just throw some caching layers around it, so latency doesn't really matter too much. Well, is your cache layer actually working properly? A lot of times your cache layer doesn't work as you expected, or you also start seeing latency on the cache layer as well. One of the things that I like also thinking about, because I worked on trying to come up with a sort of multi-cloud control plane, is your actual control plane working? Now that you have built this internally, or you're using an open source tool for this, how do you actually know that this is leveraging both, maybe you're calling them via APIs, that you're actually getting the right information, or that you actually know what is the latency of these hosts, these instances, these storage units actually showing up on your control plane? Being able to know these things by doing chaos engineering is really critical. And then we have the part that, because we're just throwing money at the cloud and we're expecting for resources to be sent to us, how do you know that you're not hitting any of the limits with your cloud providers? I know every time I try to spin up a lot of projects on AWS, all of a sudden I'm hitting a lot of limits, and it's like, I don't have support enabled for this account, so it's like having to constantly wait for technical support of like, hey, can you raise my VPCs? Can you give me more EC2 instances? It's better if you're actually testing that you have those limits extended to the max capacity that your company needs, especially if you're trying to verify that your auto-scaling is working properly for peak season. So with chaos engineering, you constantly want to ask yourselves, can we handle our failures? And this can be things of your vendors going down. What actually happens if your CI/CD pipeline goes down, or the place that you host all your code goes down? How does that actually affect all your systems? And how does that actually affect all your engineers? But then we also have a lot of failures that happen just without dependencies internally. Being able to know how these things actually affect it on a day-to-day basis really helps. And do you actually have proper documentation of what to do when these failures happen? I wanted to show you an example of what running a latency experiment is. This is using scenarios in the Gremlin tooling. And we see here that we have a latency experiment about to run, and this is injecting 400 milliseconds of latency. So for the purpose of this demo, I have an e-commerce shop that is running, and now 400 milliseconds of latency are being added to the product catalog services. This is 11 microservices running on different containers. And with 400 milliseconds of latency, we see that there's a little bit of latency on the user, but it doesn't necessarily mean that they're having a terrible experience. And being able to validate that is pretty neat. So we're now going to expand that magnitude, that blast radius, and we're now going to see that the next chaos engineering experiment that we have queued up is going to be for 500 milliseconds of latency. So how does this application handle 500 milliseconds of latency? Well, very similar to the 400. There's a little bit of that lag, but it's not enough for the user to get so grumpy that they're going to cancel the services that they have with y'all. So being able to know that in whatever cloud this is running, the 400 milliseconds of latency that is added on there still provides a pretty okay user experience. We're still able to add things to our cart, place our order hopefully, and we see that our order is complete. So everything is working as properly, or at least as we expect. Then we see that this last experiment should be ending soon. And now for this one, I'm expanding that blast radius, that magnitude, to be a little bit stronger. And with this one, we're adding 1,000 milliseconds of latency. And how do things get affected? Can users actually still use the site? We start seeing, we add something to the cart. Yeah, it's not adding. Okay, so it added, but that was a little bit too long if you think about someone like your mom trying to shop online. I know I would get a call if this is taking too long. So with the chaos engineering tool, you also want to make sure that you can stop these experiments if they're running on production, staging, or development. So I went ahead and actually halted that attack. And the reason was that it was a little too slow for what I feel should be my ideal experience for my users. So those are kind of like the ways that you can practice like either coming up with a multi-cloud strategy or actually verifying that your strategy is working. I strongly believe that chaos engineering is a must for multi-cloud environments. You want to make sure that you're verifying that your strategy is working properly, but then again, how does that actually affect the way that your business is running? With chaos engineering, you are moving from a reactive to a more proactive solution to get ahead of production issues. The reason that we do a lot of chaos engineering is to make sure that our companies stop suffering downtime and that our engineers are not constantly on pager fatigue and having to deal with incidents. You want to make sure that we are doing this in a proactive way so that our companies are a lot more resilient. I want to talk about some other chaos engineering uses, and these don't necessarily pertain to folks that are trying to think about multi-cloud, but maybe a little bit more early on or a little bit after. There's a lot of folks that are trying to figure out if it makes sense to move to the cloud and being able to say, okay, this is how much having my own DC costs right now. This is how much instances cost, and being able to compare that really, really makes sense. But then you also get to think about some of the other benefits that being on the cloud gives you. Being able to have a little bit more of auto-scaling at a faster rate than if you need to actually prepare for high peak season and you're just like, all right, we need to decommission a lot of our other apps that are not working, and can you put those servers on this other rack so that we can make sure that we have enough capacity for our next peak incident? Then we have a lot of folks that come from monolith architectures, and they kind of consider decoupling this architecture to be a little bit more microservices. Well, you want to go ahead and do that, but then you also want to validate that all these microservices can run independently, But what actually happens if one of these microservices goes down? Is this dependent to one of the other microservices? What actually happens on the front end if your payment stops working? Do you have proper error handling? Or does your complete website just crash because it's trying to hit something that gets terrible error handling and it's just like, nope, I'm done. Then we see a lot of folks adopting to Kubernetes. For some, it's just because of a hype. For some, they actually have legit business reasons for doing it. But how do you actually make sure that now this extra layer of complexity you've added makes sense and that everything is set up to work correctly? And then how do you actually think about the strategy that you want to build? Do you want to have clusters for every single microservice? Do you want to have a large cluster dependent on the region that you're running? And this brings us to other things that you can use chaos engineering for. And let's say that, well, I mean, everyone kind of at this point has monitoring and paging, alerting, any observability tool for that matter. How do you actually make sure that all these things got actually configured properly? Well, you won't know until you're realizing that the dashboard you need to actually deal with that incident is not there. Or maybe you actually didn't install observability on the microservice that you're currently trying to run. And you expect that our engineers are actually going to get paid for this, but what if you actually forgot to set up some scheduling on that, or you actually didn't set up the right alerting? You actually won't know until this actually happens in production and you're scrambling to figure it out. So being able to test those things really makes sense. And we have a little bit of more human side of things, more things that are geared to the engineers. Being able to tell them, hey, we can actually train you to how to be in on-call versus just throwing a pager in your face and telling you, hey, you're on call. Here's a runbook. Figure it out. Being able to say, okay, we're going to do training for the next 2 weeks. We're going to do some thoughtful and planned chaos engineering experiments so we can actually make sure that you know that when your pager duty alert goes off, you're in the right psychological state to deal with it, but you also know exactly what runbook to go look at, what dashboard to actually pay attention to, or what is the actual monitoring tool they should be looking at to begin with. I know various companies have more than 4 or 5 monitoring tools and observability tools. Some of the things that you want to think about when doing chaos engineering is, was it expected? Chaos engineering also helps you uncover unknown side effects of your systems that you didn't necessarily know were there. Was it detected? Ensuring that our monitoring is configured correctly is really, really critical. Was it mitigated? When possible, our system should gracefully degrade. Let's say that you're trying to send a text message and it errors out because you ran out of signal. Wouldn't you hope that the experience when it's degraded is for it to actually retry after that? That's something to consider. Then after doing chaos engineering, you want to keep a lot of these things in mind. You want to make sure to fix those issues, whether those issues happen to be code, configuration, process. You want to constantly iterate and improve. Then you want to ask yourself, can you automate this? Regularly exercise past failures to drift into failure. One of the use cases that I forgot to put on the past slide is being able to look at the top 5 incidents that have happened in your company that have cost you a lot of money, or the most recent ones. You can actually look at those incidents and build chaos engineer experiments around them, whether it's your cloud provider going down, whether it's a vendor that you use having some issues, latency, some packet loss due to the region that you're running out of. And with chaos engineering, you constantly want to share those results. You want to come up with an executive summary that sums up the findings of your chaos engineer experiments to send up to executive leadership. And some of that definitely differentiates depending on the business metrics that you use. For a lot of folks, being able, some folks actually track their mean time to detection, their mean time to resolving of incidents, being able to say, look, this is what they were before we started doing chaos engineering, and we've been doing this for a month now. We went from resolving an incident in 22 hours to 14 hours is a huge win. Being able to share those things really matters. But then you can also think about the fact that, let's say, you see a lot of failures happen with an open source software that your company is using. You're able to test it a little bit more with chaos engineering. You're able to come up with a blog post of, hey, these are some of the failures that I saw running this open source tool in production. Maybe you should actually build a little bit of guardrails around it, or you just go ahead and contribute back to the open source project. So with that, I want to share that you want to embrace chaos. Failure is beautiful. Failure is going to make us better people, better engineers, and we have to embrace that chaos. With that, I want to say thank you. If you have any questions or you want to stay in touch with me, I'm at Twitter at Anna_M_Medina. That's my LinkedIn. You can email me at anna@gremlin.com. And if you're interested in chaos engineering, please check out the Chaos Engineering Slack channel. There's over 3,500 people that are there that are either interested in chaos engineering or are actually doing chaos engineering. Thank you once again, EscapeConf, for having me. Have a great one.
Can you take a couple questions if there are?
Sure.
Yeah, does anybody have any questions? I have one. How do you get started? Right, like, because I think this whole practice is something that's new for probably most of us in the room. Probably, maybe, yeah. How does somebody get started with this whole practice, right?
Well, you can actually get started with using Gremlin for free. We have a Community Forever offering, and that includes 2 chaos engineering experiments of shutdown and maximizing a resource, which is CPU. So if you're interested, you can go to gremlin.com/free, and you don't ever have to talk to a salesperson if you do that, which is neat. But there's also a few other open source tools that you can look into. All these resources, we actually have them on the Chaos Engineering Slack channel. So that would probably be the best bet of grabbing those links. Or if you go on GitHub, you can look for the awesome Chaos Engineering big GitHub repo.
Yeah, you guys have amazing documentation and blog. I think Colton has really pulled together an amazing company. So it's awesome. So, any other questions, anybody? Yeah, here.
Great, by the way, a great Latinx speaker, which I love. So how are things evolving? I mean, Adobe's a customer, so we're kind of using it, and we have the varying groups already kind of embracing it. But in regards to the stateful areas, I know you mentioned hey, deleting replicas, all these things. But how are you seeing these things evolve, especially when some individuals may embrace in public cloud the managed stateful type stuff? So how are you guys looking at those use cases? How are you all looking at those use cases of introducing chaos, since you can't get behind those type of services?
Yeah, so we continue getting a lot of feedback from the community on customers on our product, and very much of how do they tie in when they're very specific. But for us, one of the big things that we've been seeing is that folks really want more on the Kubernetes and being able to get nitty gritty on the way that those containers are running. So that's kind of our big focus that we have on right now, where we're going to be doing a launch later in November. And then we're doing a little bit of, well, not doing a little bit, we also have another product offering for application level fault injection. And this is a little bit more of being able to test a lot of those things that are the nitty gritty of your applications, from being able to be very precise on where you're gonna run these experiments, and testing the timeouts of your application, whether it's just HTTP errors or HTTP calls or errors that get sent there. A little bit of that.
Great presentation. So I haven't used the product yet, but I understand it. And there's one aspect of it that you kind of went over, which was in doing this and actually injecting some of the faults, you can actually calculate potentially some of the costs and some of the overages. Are you actually doing that, or is it just the output then you feed into another engine? Are you looking at the actual built-in or predictability of what you're using, let's say on EC2 and S3, bring that in over a certain amount of time frame, and then giving them the output of that from a dollars perspective?
Yeah, I mean, we completely only do we do resiliency only. So we only have a chaos engineering platform offering. But we're definitely looking at what are going to be some other things that we can help companies. Right now, with that example of looking at those costs, you very much have to go build those clouds by yourself and then go look at your billing and basically compare. We don't really have an offering for that. But I think that's great product feedback that I'll definitely go send out to our executives.
Hey, Anna, just as a follow-up, is there an API to the data itself where somebody could integrate on top of it and build something like that?
Yeah, we have an API, a CLI, and a UI. With the API, we have a few integrations already with some monitoring tools, with a CI platform. So even if you just want to play around with it, integrate it to another resiliency tool you have in your company, you're more than welcome to. And if you have questions about that, you can always email me, and we have on the Chaos Engineering Slack channel a support for it, the API as well.
Cool.
Thank you.
One last question from Sebastian from Google.
Yeah, thanks. Love the talk. I love chaos engineering. It's always super fun. I love talking about like fault injection, especially when I talk about service meshes, which was kind of like the TLDR that I had of the earlier panel. It's open source and service mesh, and then I'm a happy camper. However, being that I'm a DevOps guy and I want to do more interesting things with that, what's interesting that I see a lot when I talk to customers is the way that you make a change, whether you roll back something, is through a CI/CD pipeline. So in other words, if something broke in production and we need to like make a change on something, we're not doing chaos engineering or anything like that. We just, something broke, we need to make a change. It's, quickly, git, commit something or other, go fix something, and then you're all set. What I would love to do is have a holistic approach to chaos engineering. And I would like to be able to apply chaos engineering principles to the CI/CD pipeline. Because if that thing breaks, y'all are up a creek without different types of paddles and things like that. So I'm just curious if you've heard of people doing chaos engineering on CI/CD pipelines. Any interesting lesson learned? Does it need to be out of band? Like, how do you do that?
I want to say that I don't have any lessons learned from any of our customers or anything like that, or even like we're not doing that yet. We do have that API that is easy to do it, and we actually do have an integration with Spinnaker that allows you to do that, so major clap on that one. But basically, you're actually able to do it in a way that you do that. You actually deploy something, you run a chaos engineering experiment on it, and then let's say that actually fails, you tell it to actually not commit that to prod. So there is that other aspect of doing it.
That's awesome.
Awesome, thank you. Anna, thank you. That was tremendous. That was a really, really great conversation. So we're going to take a break now. So I saw donuts up there. There are small little donuts upstairs. And I think we start back at 3:20. So it's about a 20-minute break. I'm not sure what's after the break. I'm too much in my head right now. So thank you, everybody. So we see you back in about 20. Have a donut.